Welcome students in our virtual classroom. Today I will discuss a very important topic of engineering graphics and design, that is isometric projection. Already we have discussed the orthographic projection, where we have drawn different view, means the front view, top view of various object, making a section of the object. Now it is the isometric view. What is this isometric view? Before this class of engineering graphics, if I am asking you to draw a image of a book, then what types of image you should draw? That view is the isometric view. Means say it is a cylinder. In that case, in the front view, if the cylinder placed on the ASP on the table here, the front view, you know, that is a rectangle, the top view is a circle. But when you will look from a certain angle, you can see the top surface, ellipse, that looks like an ellipse, and as well as the curved surface. So combination of these two is the isometric view. Actually, there is a certain angle from which we have to see the object. That we are going to discuss in detail. Here I will show with the help of a book how isometric view looks like. In the roadside, we have seen a number of ads of different flat, this complex, housing complex. So what view they are showing? They are showing the isometric view of the complex. And when you are going to buy the flat, then they will show you the layout of your particular flat. That is the orthographic projection of that flat. Very simply, this is one of the practical difference between the isometric view and the orthographic view. Let's see in case of a book what it looks like. It is a book. When we are looking exactly perpendicular to one of the surface of the book looks like a rectangle. It is the front view. And again, if we look from perpendicular to another surface, this surface is another rectangle. But if we look the book like this, then this is the isometric view. I repeat, this is the isometric view. Means now the vision is not perpendicular to any of the surface. Rather, it's make an angle. As I have told you, that in any construction, when we are seeing the ad of a building, then what view they are showing? That is not orthographic view. That is the isometric view. Means what? You can see this top surface as well as the front surfaces of the building. So this is what the isometric view and isometric projection. Now what is the principle? Iso means equal. Then what is equal here? Equal angle between the axes. Then what are the axes? Let's place a cube, this cube, A, B, C, D, E, F, G, H, such that one of its diagonal, body diagonal means if you draw a diagonal from the C end to E end or B to H, means if you join one corner of the base to opposite corner of the top, then that is the body diagonal of the cube. Now if you place the cube such that this body diagonal is perpendicular to the HP, or the body diagonal is perpendicular to VP. Body diagonal means a straight line, and if it is perpendicular to VP from line projection, we know that it looks like a point, this point. Then GA is a point. Actually, it is the body diagonal. A is the point of the top surface, this point, and G is the point on the bottom. And when this body diagonal means this straight line is perpendicular to the VP, then from front it looks like a point. We know it. And in this situation, if you draw the view, the front view, then that is the, or top view, then that is the isometric projection. And what is happening? What's the drawing method? Now, if you draw three axes, X, Y and Z, they are equally inclined. Means all the angling is 120 degree. Now, what's the drawing method? If you draw a line here, then as I have told you, it is 120 degree, and it is equally inclined, means these and these angle is same, and totally this is 180, so it is 30 degree angle. Now if we draw this line BD, it is the diagonal of the top surface, not body diagonal, it is the diagonal of the top surface. But for these three surfaces DC, CB and BD, as it is a cube, so DCB, it is a right angle triangle actually. But here it does not look like a right angle triangle. Means this length DC has been reduced. Then what is the actual length? If we draw this line DC at 45 degree angle, then now it is the right angle triangle. And this DC dashed is the actual size, actual length of the object. But in the isometric view, it looks like DC, which is the reduced length. Then from the actual length, how we are getting the reduced length, that we have to see. If these are three axes, so they are making equal angle 120, and that's why, as I have told you, that it is iso means equal, so the angle between the axes are equal. Now let's see this angle DC. So DC dashed cos 45 equals to D to this point. Again DC cos 30 equals to this length. So DC cos 30 equals to DC dashed cos 45. So from there we are having this equation, DC by DC dashed equals to cos 45 divided by cos 30, which is equals to 0.816. So this is the ratio of length actual to isometric view. In the isometric view, it is reduced. With respect to actual length, the isometric length is 0.816 times, or the ratio between actual length and isometric length is 1:0.816. Now using that reduced length, it will be helpful to make a scale from where directly we can take the measurement and draw the isometric projection. How we will draw it? So let's draw this line, then draw a 30-degree line. 30-degree line means this is the isometric length scale, and say it is the actual length scale. So actual length scale means it is the true scale, whatever may be the counting. Now draw the projection line, project this length to the isometric length or isometric scale, make the project, and then this is the length. So corresponding to 0 to 5 dashed, if it is the actual length, then isometric length is 0 to 5, and so on. So this is the true scale and it is the isometric scale. So from this scale we will directly measure the length, take the length to draw the isometric projection. And this is the ratio that already I have discussed here. Now let's see how to draw the isometric drawing or the isometric view or isometric projection. We are starting with a circle. How to draw a circle? The dimension of the diameter of the circle that is given. So draw this line. Then we have this scale. So from this scale, whatever say the length of the circle diameter is 4, 0 to 4 dashed. So in isometric drawing, we will draw 0 to 4. And circle, so before drawing the circle, we will rather draw a square which looks like a rhombus, as we have seen in a previous picture, that the surface of the cube looks like a rhombus. Now we have to draw that rhombus, and then the angles is AB length is AB, and this is the 30-degree angle, and here it is other angle. Then draw equal length from here and here and join it. So this is C point to join it. Then the circle is within this square, which looks like a rhombus. So get the midpoint of the rhombus side. This is the midpoint, E. Similarly, FG is. Now we have to draw the ellipse. A very common method to draw is join the C and the midpoint here, C and this midpoint, A and this midpoint, A and this midpoint. Then say this intersection point is P and this intersection point is Q. Now draw this arc GF. How we are drawing this GF arc? It is the arc at radius AF or AG, and starting from G and ending at F. Similarly, we can draw this arc H to E, where center is C and radius is CH. Then draw this part. So how we are drawing it? Your center is now Q and QF is the radius. Again, in this side, P is the center and PG or PH is the radius. Now we have completed our drawing of circle, which looks like an ellipse here. There is a little bit difference between isometric view and isometric projection. If we don't scale down true length to isometric length, then that view is called the isometric view, because means in the isometric view also we are taking the same measurement, means actual length. But instead of actual length, if we take the isometric length, then that projection is the isometric projection. See here, it is a cuboid, image of a cuboid. The red cuboid, it is due to isometric projection, whereas this gray cuboid, it is the isometric view of the cuboid. Pattern is same, only difference of dimension. Here this one is taking actual length of the cuboid, but here the isometric length of the cuboid. Now we will discuss isometric projection of a prism. Say the statement of the prism is as given. So it is a hexagonal prism. So base is a hexagon with side 30 mm and height of the prism is 70 mm. Rest with its base on HP. Simply it is placed on HP. The orthographic view of the prism is given. So what orthographic view? This is given. Now what to do? We have to draw the projection. Isometric view of this prism. For which orthographic view is this? Means this is the front view and this is the top view. Now what are the steps? So first, for this hexagon we can draw a rectangle. Three axes are, this is one axis, it is another axis, and the height is the third axis. Maybe that is the z axis. And out of these two axes, it is either x or y. Now how we will start it? As it is the projection, so we have to take the actual, not actual length, but the isometric length. So we will use this scale. Then what is the dimension? 70. So first this is the 70 length. So corresponding here to here is the isometric length of that 70. This is 60, then this is 70. Then another important dimension is if it is as this is 30, so this length is 60. But what is this? Take this dimension from this figure and cut it here to r dash. This s dash to r dash equals to 0 to this r dash. Then project this length here. So for s dash r dash, the isometric length of this side is here to here. Now take the measurement. The angle is the 30 degree in both sides. Here is the S point and this is the P. So for SP the length is 60, means this is the length, and corresponding isometric length is this. So take this length equals to SP. And these A's are equals to here to here. These are point. And angle we know. Now complete the parallelogram. So we have completed the base. Now draw perpendicular line PT from all these points. What's the length of this PT? Equals to this height 70. But 70 means this 70. In isometric scale 70. So this is the 70. So draw. Then find the midpoint here. Why midpoint? Because you notice that this D point is on the midpoint of RS. So it is the midpoint of RS. Then here also it is the midpoint. And this is E. So how we are getting this E point? You can take this measurement S dash to E from here and scale down it using this scale and cut it from here. And similarly we are getting this point, C there, C, F and B. Then draw the perpendicular line from all this sides and then join all these points and get the corresponding points here also. 1, 2, 3, 4, 5, 6. So these are the 6 points. The 6 point on the base is A, B, C, D, E, F as here, and the top 1, 2, 3, 4, 5, 6. Now join. After joining the point, we are getting the hexagon, the isometric hexagon, the vertical lines and the base. So finally, this is the isometric projection of the prism, where we have used the isometric length. Now we will try to know about isometric view of a cone. The problem statement is here. This, the base of the cone is 60 and height of the cone is 80 and it is also resting on ASP. Then this is the view. The top view is a circle and front view is a triangle. Then how to draw the isometric view of the cone. So again we can draw a square here. This square, within the square the circle meets the midpoint of the square. So this square in the isometric view it looks like a rhombus, so draw the rhombus. And here you note isometric view, so you need not consider the scale. Use directly this dimension and draw this PS and SR and complete this. Get the midpoint as on the circle meets the touches the square or on the midpoint only. So whatever ellipse you are having, the that will touch this parallelogram at the midpoints ABCD. Then using that method we have already discussed that how to draw the ellipse. So that method we can draw it. And now join the PR and from the center draw O to O dash. So what is O? It is the apex and this O dash is the center of the base. So O to O dash is the axis and length of this axis is 80. Now complete the ellipse by the method that already I have discussed. Then draw a tangent from O to that ellipse, both sides. Then this part is inner part of the ellipse, so it is not visible. So only draw this part, complete this part. So hence we have completed our drawing of isometric view of a cone. Finally, we will learn how to convert isometric view to orthographic view. Let's see that the isometric view, this is given with all its dimension. Now, how it looks from front, top or side? If we look, the dimension is given, and if we look from this side, front, then how it looks like? The shape is this part only we will see, the L shape. So if we the observer, our eyes on that side, then we will draw the projection from this side, from all these corner points of this face. And if we draw from all these corner points also, that will overlap these projection lines. So finally we are getting this. Then draw here this, then from this point to this point, and complete it. So this is the front view. This part only we will see. And in the top, this plane is perpendicular to this plane, and if we are seeing from that side, from the top, we will see this surface and this surface. Then draw the projection line from all points. So these are the projection lines. Then we will see these and this surface, and this is perpendicular to the HP, so we can't see from the top view. So these are the view. So this is the front view and this is the top view. But actually the front and top view, this is the orthographic projection. It should not be drawn like this. Rather it is a perfect rectangle. So how we will draw it? The drawing method is, first we will draw the RL, reference line, and above which is VP, below that it is the HP. And what is the dimension? This is the front view on VP. So it is VP, this plane is the VP. So front view we have to draw this. Then this dimension 60, this dimension 40, 40, 80. So draw it. One by step by step draw it. So this is the front view. Now draw the projection from different points, and you draw this line. So finally our objective is to draw this front view and this top view. I have explained here the procedure, how we are looking that. So why this shape is like this? Because if we look the object from there, it is like this, and we look from there, then it is like this. These all are the references that I have used to prepare these video lectures.
Okay, this is the summarize. We have summarized here the isometric view, isometric projection, and orthographic to isometric and isometric to orthographic transformation. Thank you for your patience and listening to lecture, and I will expect that in future also you will attentively listen to the subsequent lectures. Thank you.